Hi, welcome to my video on circles. And this video is on converses, and it's converses number 1. When a compound statement is written in an if-then form, it is called a conditional sentence. A conditional sentence consists of two parts, an hypothesis and a conclusion. The hypothesis is the part following the if, the conclusion is the part following the then. State the hypothesis and conclusion of each sentence. We have the sentences here, conditional sentences, and we have H as C for hypotheses. If a triangle has 3 equal sides, then the triangle is equilateral. So the hypothesis is if a triangle has 3 sides equal, that's the if part, the then part, then the triangle is equilateral. So the part before the if is the hypothesis, the part after the if is the hypothesis, the part after the then is the conclusion. Number 2, if two chords of a circle are equal, then their intercepted arcs are equal. So the hypothesis is the if part. If two chords of a circle are equal, then, look the spelling on then, look like there, then their intercepted arcs are equal. And one more, if a polygon is an octagon, then it has exactly 8 sides. If a polygon is an octagon, then it has exactly, let me spell right, 8 sides. So that's introducing the conditional clause. Now let's look at another part. Converse of a conditional sentence is written by interchanging the order of the hypothesis and the conclusion. Let's do a couple of examples. A conditional sentence. If an angle has a measure of 90, then the angle is a right angle. So the converse, we switch it around. If the angle is 90-degree angle, is a 90 angle, is a right angle. If an angle is a right angle, then an angle has a measure of 90 degrees. So again, the if part becomes the then part, and the then part becomes the if part. So it's just interchanged or switched around. Another conditional sentence, if a chord passes through the center of a circle, then the chord is the diameter. So the converse, if. So the chord is a diameter. So the chord of a circle has to be on a circle. The chord of a circle is a diameter. Then a chord passes through the center. So a conditional sentence is reversed. We look at its converse. A converse statement, a conditional statement is always true, the initial statement. So if an angle has a measure of 90, then the angle is a right angle. If a chord of a circle passes through the center, then the chord is a diameter. So the conditional sentence is always true, but its converse might not be true. Let's check a couple statements that I have written. If state the converse of each. If false, state why. If 2x equals 8, then x is 4. So its converse is if x equals 4, then 2x equals 8. That's its converse. But is the converse true? So if we have x is equal to 8, do we have this equation? So we could have it's false. Why? Because if x is 8, then I could have 3x equals 12. That's a different equation. If x equals 4, then I could have x plus 2 equals 6. Again, a different statement. So just because when x equals 4, I could have many equations that would make it true. But so it's not necessary to be 2x plus 8, because it could be these two or it could be many more. Let's continue. State the converse of each, and if false, state why. If a triangle has 3 sides equal, then the triangle is equilateral. So the converse, we switch around. The converse is if a triangle is equilateral, then the triangle has 3 sides equal. So that we know the statement is true. So if a triangle is equilateral, has 3 sides equal, that's true. So the converse is true. Number 3, if y minus 3 equals x plus 1 all squared is the equation of a parabola, then negative 1, 3 is its vertex. So that's true. When x is negative 1, that's a 0. When x is 3, that's a 0. So its converse. So what's its converse? If a parabola has a vertex of negative 1, 3, then its equation is y minus 3 times equals x plus 1 all squared. That's an equal sign there. And this converse, so its converse is switched around, or the conditional sentence is switched around. So if a parabola has a vertex of negative 1, 3, does this equation have to be this? No, so it's false. Why? Because I can have a vertex, so the vertex is negative 1, 3, but I could have this equation, y minus 3 equals 2 times x plus 1 squared. The vertex is still negative 1 and 3, but the equation has the a value is 2. Or we could have y minus 3 equals negative 1 quarter x plus 1 squared. Again, the vertex is negative 1, 3, but the a value is different. So it's a different equation, still having the same vertex. So it's the converse is false. Number 4, if the chord of a circle intercepts equal arcs, then the chords are equal. So the converse is if the chords of a circle are equal, then the chords intercept equal arcs. And again, that's true. So what we're saying here is that the conditional sentence, if the chords intercept equal arcs, so if these two chords intercept these equal arcs, so if these chords right here intercept these arcs here that are equal. So these two arcs, so if x, y equals a, b, so if the arcs are equal, then the chords are equal. So that means x, y is equal to ab. The converse is if the chords are equal, and let's do this. So what we have is named the same way. So if the chords are equal, so if x, y equals AB, so that's the chords, then the arcs are equal. So the arcs are equal. That's the converse, and the converse is true. Number 5, if x plus y are, if x and y are even integers, then their sum is even. So the converse is if the sum of x and y is even, then x and y are even integers. So this converse is switched around, so x and y are even integers is in the then, and their sum is even is in the if, and so this is false. Why? Because the sum of two numbers, so notice 1 plus 3 equals 4, so the sum of x and y is even, but x and y are odd. 1 and 3 are odd. Even integers are divisible by 2. Odd integers have an odd number added on. So 1 and 3 are not divisible by 2. And we could have 5 plus 5 equals 10. So 5 and 5 are odd also. So any two odd numbers adds up to give you an even. If you take 11 and add on 3, you get 14, which is even. So 11 and 3 are odd. So that's just going over conditional sentences and their converses, because in geometry or in any part of the math, we can have conditional sentences and their converses, and the converses don't have to be true. So that brings us to the end of this video. If you like my video, click on the like button. If you want to be a subscriber to my channel, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.